In this demonstration, we want to create a confidence interval for patient wait time. We'll use the file patient data. Let's open that file and get started. We'll study wait time in this case, which is column G. The nice thing about confidence intervals is that you already know how to create them. Simply go to Statistical Tools and Descriptive Statistics. We'll use the entire table next, and our focus is wait times. We'll select that as the Y. Before we go on, note that if you wanted to create confidence intervals by office, we could include that as X1. If you wanted to do it by day of week, by gender, by type of patient, whatever, this allows you to do a main variable, but you can also categorize it out by several other variables. In this case, we're focused just on wait time. And notice this box down here that says confidence level. We want to maintain a 95% confidence level. We punch OK. And we immediately get these results. Let's enlarge those a little bit. And it gives us the same thing that we saw earlier in descriptive statistics, but in this lesson we're going to focus on rows 11 and 12, which are confidence intervals. Let's move this over to the virtual whiteboard and talk more about it. Before we dive into these numbers, let's take a look conceptually at what we're really trying to do here. We'll make up a number. Let's assume that your practice has a total of 1,000 patients. That would be your population. And we don't know what the mean and the standard deviation, what mu and sigma are of that population. The only way to know for certain would be to track down all 1,000 of those patients and study them. We don't have the time, money, or resources to do that. Therefore, Greenbelt projects rely on sampling. So in this case, what the count is showing you in descriptive statistics is that we took a sample of 100 of those patients. From that sample, we're able to calculate the mean and the standard deviation, X bar and S, of the sample. Then we will use confidence intervals to make a guess or an estimate, an educated estimate about the population parameter. It's a bit like taking a spoonful of soup and trying to determine if the entire bowl of soup is too salty or not. We're taking a sample of 100 patients and we're making an estimate about all patients based on that. Could that estimate be wrong? Absolutely. Therefore, confidence intervals will generate a margin of error for us. Let's take a look at this. What these numbers are showing you in the descriptive statistics output are the sample mean and the sample standard deviation. Those are X bars and S's. In other words, we took the wait time of all 100 patients, added them up, divided by 100. That's where we get the 29.02. Now from this, we would like to create confidence intervals and make an estimate about the population mean and standard deviation. That's what these are here. Those numbers are your estimate. Because this estimate could be wrong, it gives you a range of numbers. This incorporates a margin of error. And what these numbers are trying to tell you for the mean is this. We are 95% certain that if you went and studied the wait times for all 1,000 patients, that the true population mean, mu, would fall somewhere between 27.83 and 30.21 minutes. And we're 95% certain of that estimate. We can create one of those for the standard deviation as well, and that tells us that based on our sample, we are making an estimate about the population standard deviation, and we are 95% certain that if you studied all 1,000 patients, that population standard deviation would be 5.25 and 6.94. If you wanted to create a confidence interval for the variance, you would simply square those numbers. These are used as the engine that drives most of the statistical tools we'll be showing you later in this section. Confidence intervals work best if the data are normal. In this case, the Anderson-Darling normality test gives us a high p-value indicating that data are normal, and we can trust these confidence intervals. We use these a lot. They're primarily used behind the scenes, but we will also be referencing these a great deal in this section. That's confidence intervals. Let's move on and learn some more.